Okay, the concept of coordination complex, the branch of inorganic chemistry that deals with study of coordination compounds is called coordination chemistry. We'll further discuss concept of coordination complex, lesions or coordinating groups, complex ion, neutral complex, coordination number of central metal atom or cation, coordination sphere and ionization sphere, monodentate and polydentate lesion, effective atomic number rule. First of all, lesions are coordinating groups, the molecular or ionic species which get attached directly to the central metal atom or ion during the formation of complex compound are called lesions. The lesions are attached to the central metal atom or ion through coordination bonds, so that lesions also called coordinating groups. The lesions are commonly negative ions, for example, chloride, bromide, or neutral molecules, for example, ammonia, carbon dioxide, nitric oxide, containing lone pair of electrons, for example, in the complex ions, hexa-ammonium cobaltate, the 6 ammonium molecules which are attached with central cobalt ion act as ligands. The Lewis says in most of the complex compounds, the ligands act as Lewis base, that is electron pair donors, and the central metal ion acts as Lewis acid, that is electron pair acceptor. That is, the ligands donate one or more electron pair to the central metal ion, forming ligand metal coordinate bonds. For example, metal plus ligands forms complex ions. Central metal ion compound, that is the electron pair acceptor, and ligands electron pair donor. Complex ion is a positively or negatively charged species which contains a central metal atom and a suitable number of ligands attaching the central metal atom or ion. The complex ions should be closed by the square brackets. For example, complex ions are cationic complex ions and also anionic complex ions. The complex ions may be cationic or anionic complex ion depending on the nature of the charge on the complex ion. Cationic complex ion has positive charge on it, while the anionic complex ion has negative charge. Neutral complex or complex which has no charge on it is called neutral complex. It is a non-electrolyte and does not undergo ionization, so that it does not give any ions in gaseous solution, for example, neutral complex. Coordination number of central metal atom or cation, coordination number of the central metal atom or cation is a given complex compound is equal to the total number of donor atoms which are actually attached with the central metal atom. For example, coordination number of cobalt third and in this complex compound is 6, and coordination of cobalt, and in another one this complex is also 6. Coordination sphere and ionization sphere. While writing the structural formula of a given complex compound, the central metal atom and the lesions attached with it are always written in the square bracket. This part of complex is called coordination or inner sphere. The portion outside the square bracket is ionizable or outer sphere. For example, in these complex compounds, the square bracket which contains the central cobalt and third ion and the ligands 5 ammonium molecule and 1 chloride ion is coordination sphere. And the portion that contains 1 chloride ion is the ionizable sphere. Monodentate and polydentate lesions. First of all, monodentate, that is the unidentate lesion. If lesion is attached to metal atom only by one coordinate bond, then the lesion is known as monodentate or unidentate lesion. These lesions have only one donor atom or are coordinated to one electron pair. For example, chloride, cyanide, hydroxide, ammonia, water, etc. Polydentate or multidentate lesions, lesions having two or more than two donor atoms are called polydentate lesions. Depending upon the number of donor atoms, the lesions are classified on didentate, tridentate, tetradentate, pentadentate lesions having 2, 3, 4, 5 donor atoms respectively. For example, uh, ethylene diamine is the bidentate lesion. EDTA is a hexadentate lesion. Effective atomic number rule, the Sedgwick suggested that after the lesions have donated a, a certain number of electrons, certain number of electrons to the central metal ion through the lesion metal coordinate bonding, the total number of electrons on the central metal ion, including those gains from the lesions in bonding, is called effective atomic number of the central metal atom. Certain number of electrons to the central metal ion through the lesion to metal coordinate bonding, the total number of electrons central metal ion, including those gained from the lesions in bonding, is called effective atomic number of the central metal ion. Effective atomic number of central metal atom or ion in a given complex is given by the formula effective atomic number equals Z minus X plus Ny, where Z is the atomic number central metal atom, X is charge oxidation state of the metal atom, and number of lesions, and Y the number of electrons donated by the lesions. For example, effective atomic number of cobalt in this complex compound is calculated. Atomic number of cobalt 27. Oxidation state of cobalt 3, so 27 minus 3 plus that is the 6 ammonia lesions, and it donates 2 electrons, so 36 is effective atomic number